The moment they come in contact, so this will come in contact. When it comes in contact, anything should happen. The way impulse will start acting. Impulse will start acting. What direction that impulse we have to take it. This is a test. The impulse will act. So next diagram I'll show that an impulse will act. And the moment impulse acts, what is impulse? Like a force, no? That normal force acting for small duration of time. So here, this is M1, M2, and impulse will start acting here. The moment impulse starts acting, so this will acquire some velocity, say V1 dash. And this will start moving V2 dash, and see that I shown some deformation. They'll undergo deformation. Then like this, the deformation will continue. V1 double dash, V2 double dash, and finally how the shape, it all depends upon the type of bodies, everything. I'm just showing some rough diagrams. And at one instant they'll have common velocity. Here let me show that impulse like this. So this impulse I'll give name deformation, I'll call it. What that impulse acts, no? I'll call this as impulse of deformation. Now both will have common velocity. So you can say really we have enough concepts we have covered related to this. Sir, why they should have common velocity? We have enough discussion we have made. Spring block system. Elastic collision means you can treat like these two blocks are connected by a spring. So bring back that ideas what earlier we learned. Then after this, you go back to spring block system. I'll keep this particular. You can connect to spring to this or that one, either of one. So initially, spring is relaxed. Impulse of deformation. Impulse of deformation. Okay, now this spring, what will happen? It's relaxed, it will go and collide. So now the moment it starts come in contact, the spring will come in contact. Still it is relaxed. Now what it will do? It will compress, the spring will get compressed, so we'll get a spring force, kx1, kx1. Then this will start acquiring velocity v1 dash, v2 dash. So it was moving. Now the velocity will slightly change. No? V1 dash should be less than u because of spring force acting. Then again the spring will further undergo deformation. Please recollect all. So there's nothing to bother like, sir, why you are writing all this? So this will be kx2. So it will have v1 double dash, v2 double dash. And at one instant, both maximum compression. Tell me what should happen to the speed of the blocks. Both must have common velocity. Will I agree? This is the maximum compression. No? Tell me after this what will happen. No, both are having common velocity. Both are having common velocity. Maximum compression. I'm showing it like this. Maximum compression. Both are having common velocity. Look at the spring force on the first block. It is acting towards left. So velocity of this will decrease. And what will happen to velocity of this will further increase. So shall I say it comes out of compression? It comes out of compression. So here what is the phenomena that will take place? It will be compression only, but not maximum compression. So here if I take it x3, kx3, so this will have velocity say v1 triple dash, v2 triple dash. Can you say anything about the x3? No, x3 will be less than xm. x2 will be same situation here also. So what we can make the bodies here now? They will start coming out of maximum compression here, maximum deformation. So now, so here shall I say it starts reforming natural length. What spring likes to be? Spring wants to be in natural length. Spring always wants to be in natural length. So this in a it's a compression. This is also a compression. Please notice this because this is a concept. If once you have this rest all mathematics, very easy. This topic is very easy. Only the theoretical part clarity will not be there because books also didn't discuss exclusively all this one. Compression, maximum compression. So from maximum compression, not immediately natural length or maximum elongation. Maximum compression, compression decreases, then natural length, then again elongation, then elongation increases, maximum elongation, like this. That phenomena continues here. So since it is connected like this, no, it is not connected to block M2. We'll just proceed till here. Now after this, what should happen? There maximum compression. After maximum compression, again there'll be a compression only, no? So shall I say that the blocks got deformed? Now what they do? They'll try to come out of deformation. So after compression, the compression keeps on decreases. Tell me after this what will happen? Because this is not connected. The block M2 is not connected to spring. Only M1 is connected to spring. Please notice this. What is the sequence will take place after this? The theory I'm taking help of the blocks. What all the theory I'm trying to discuss now, I'm taking help of the spring block system. After this, what should happen? The blocks. I don't have space there, so shall we take like this? The blocks lose contact, compression keeps on decreases, and at one instant, if the velocity of the block is V2, velocity of the block is more than this, then it lose contact here. So here we'll have finally V1, this V2, and x equals 0. So altogether, what happened here? The blocks came, collided, or so like a spring got compressed, maximum compression, then compression decreases, and finally the block M2 will lose contact from the spring. The same situation here gets repeated. So after this, the velocity of this will be V1 triple dash, V2 triple dash. Here the impulse that acts, it will try to reform the bodies. One more, we'll take it. And finally, what will happen? The bodies. This will acquire velocity V1. This is V2. This I'll call only J. It will be much easier for us. This everything is what you can call process of reformation. This above one phenomena, you can call that as deformation. So what is JR and JD? JD is impulse of deformation. And what is JR? Impulse of reformation. Okay, what happens in the collision phenomena? The bodies come and collide, they'll undergo deformation. The deformation will be maximum here, maximum deformation here. Again, they'll come out of the deformation. Then finally, they lose contact. Okay, let's see that what is the net impulse acting on system? Total impulse. No, or net force, center of mass idea also. So this J, normal contact acting for small duration of time, is what? The impulse, no? What is the net force acting on system along x-axis? 0 plus JD, you see everywhere. Plus JD minus JD, plus JD minus JD. Here plus J minus J. Here what about plus JR minus JR? And finally, they lose contact. So what is the net force acting on system along x? 0. Or net impulse is 0. If impulse 0, momentum is conserved. Or force 0, momentum is conserved. Can I apply conservation of linear momentum? Yes, the answer is yes. We can apply conservation of linear momentum. So first equation I'm bringing. The net impulse acting on system along x-axis 0. So therefore momentum is conserved along, since we are discussing motion along x-axis, so I'm writing like this. Or if you're getting confusion with impulse, so write fx here. So what is the initial momentum of system? m1u, m1u, m1v1 plus m2. Since we are discussing along x-axis, I'm not writing that v1 bar, v2 bar. So this is the conservation of linear momentum. So in collisions, can you apply conservation of linear momentum? The answer is yes, very much. Because net impulse acting during impact will be 0. Okay, after this, now what about, can we apply conservation of kinetic energy? Not total energy, conservation of kinetic energy. Yes, it's an elastic collision. So what is elastic collision? The bodies, they come, they collide, they'll undergo deformation, they'll attain maximum deformation. Again, what happens? They will reform. So they'll retain shape. And finally, if you check it, no, the bodies, what will happen? No deformation. So no deformation is left out, or no residual deformation. No residual. Residual means, all of you, technical word, residual, leftover, no residual deformation. The bodies come, collide, undergo deformation, then they will come out of deformation completely. Then such collision is said to be elastic collision. And when I check it, initial kinetic energy, it's equal to final kinetic energy. So therefore here, initial kinetic energy equal to final kinetic energy. So m1 u square by 2 should be equal to m1 v1 square by 2 plus m2 v2 square by 2. How many unknowns are there? v1, v2. Solving equation 1 and 2, I'll get the required answer. So like this, what happens? If a collision occurs, elastic collision occurs, we can apply conservation of momentum, and kinetic energy is conserved. I should not say kinetic energy remains constant. Any reason for that? So we'll take help of, look at this. So what's happening to kinetic energy of system? It keeps on decreases. Kinetic energy, I'll write it in short, kinetic energy of system decreases. Here it will become minimum. Kinetic energy will be minimum. Here it will be minimum. Then again, what happens? The kinetic energy of system starts increasing. And this is the final kinetic energy. And this was initial kinetic energy. And what will happen? Initial kinetic energy is equal to final kinetic energy. So what's happening to kinetic energy of system? It decreases. Where that decrease in kinetic energy gone, converted into increase in potential energy. Sir, I'm not seeing any spring. If the body undergoes deform, nothing but what happens? Elastic potential energy increases. Or we call that as deformation energy. Here, that's why I just brought the spring idea. Are you getting that one? Here, in what form the energy is present, in what all form energy is present, in the form of kinetic energy and also deformation energy. The deformation energy, you can call it as elastic potential energy. So here, the deformation energy will be maximum. So the kinetic energy decreases, the decrease in kinetic energy got converted into increase in deformation of energy. Then again, the body starts, the system starts reforming. Means the body starts undergoing, trying to retain the original shape. So the potential energy decreases, kinetic energy increases. Finally, what initial kinetic energy is, the same kinetic energy it will possess. So what about potential energy here? Will be zero. So therefore, what is the kinetic energy? Shall we say constant or conserved? Kinetic energy remains constant or is conserved? Kinetic energy is conserved, you have to say. If you say constant, I think there's a problem, no? So in elastic collisions, what happened to kinetic energy of system? Kinetic energy of system is conserved, not it varies. So it's not a constant. So in elastic collision, kinetic energy of system is conserved. That's all. But you should not say constant. Kinetic energy of in elastic kinetic energy of system is constant. Wrong statement, because it it is having some initial value, decreases, becomes minimum, then again increases, again attains the initial value. Finally, it attains the initial value. So therefore, conserved word is very important, not constant. Now, please do uh, analyze this. These are very important ideas. Because see, the whole 2 weeks will just revolve around this basic condition, nothing big. So no residual deformation. These are very important. Okay, let's see that how to calculate that deformation energy. Can we calculate that deformation energy? So I'll take help of these two. So let's take one example rather than this.